Okay, so homework 14, standard deviation and the 5-number summary. So the standard deviation is getting at how widespread a data set is. The smaller the standard deviation, the less spread out the data is. The larger the standard deviation, the more spread out of a data set we have. The 5-number summary will hit when we go over problem number 3. So consider the following 3 distributions. They're all drawn to the same scale. Identify the 2 normal distributions, and then of the 2 normal distributions, which one has the larger variation. So a normal distribution is this nice symmetric distribution. So the 2 normal distributions are going to be A and B. Recognize C does not have that nice symmetric shape, and from the last homework we saw that C is in fact a right skewed distribution, so it is not a normal distribution. Again, a normal distribution has this nice symmetric shape. This shape is referred to as a bell curve, if you're curious. So we want to identify which of the 2 normal distributions has the larger standard deviation. So the larger standard deviation corresponds to the wider distribution. So A will have the larger standard deviation between A and B. Okay, let's jump to question 3. So the following 4 sets of 7 numbers all have the same mean of 9. Complete parts A through D. Alright, so we want to make a histogram for this set of all 9s. So recognize the data value is 9. And it shows up 7 times. So we want a data value with 9 that shows up 7 times. So showing up 7 times corresponds to a frequency of 7. So the data value of 9 and a frequency of 7 would be C. So do keep in mind C and B look very similar, but notice the labels on the axis are different. Make a histogram for this one. We have 2 8s, 3 9s, and 2 10s. So we have a data value of 8 showing up twice, 9 showing up 3 times, and 10 showing up twice. So that would correspond to this histogram. Recognize we have 8 showing up twice, 9 showing up 3 times, and 10 showing up twice. Make a histogram for this set. Well, 7 has a frequency of 3, 9 has a frequency of 1, 11 has a frequency of 3. So it looks as if B is going to be the correct option. Again, match the data value to the frequency of how often they show up. Okay. Make a histogram for this set. We have 5 showing up 3 times. We have 9 showing up once, 13 showing up 3 times. So it sure seems like B. Yep, B. Again, B and A look pretty similar, but recognize the labeling on the axis is different. So here's the 5-number summary, and all the 5-number summary is really giving us is the low value, the high value, the middle value, and then these quartiles are essentially the middle value of your bottom half. The upper quartile is the middle value of your top half. So we want to do a 5-number summary for this set of data. Well, the data is all 9, so 9 is going to be the low value, the lower quartile, the median, the upper quartile, and the high value. Draw a box plot for this. So a box plot looks something like this. It's also referred to as a box and whiskers plot. So this is your box, and these are your whiskers. This will correspond to the low value. This will correspond to the high value. This vertical line corresponds to the lower quartile value, also referred to as Q1. As you might anticipate, this vertical line will refer to Q2. And we also have a vertical line that falls in between Q1 and Q2. I'm sorry. Probably should, that's Q3 rather. Q2 would refer to the median. So, a box and whiskers is simply a graphical representation of the 5-number summary. So it goes low value Q1, middle value Q3, and then the high value. So recognize the low Q1, median Q3, and the high value are all 9 in this case. So we get a box plot that looks like it has collapsed into a straight vertical line. So this is kind of a bad representation of what a box and whiskers plot will look like. But we'll see some more examples. So give the 5-number summary for 88, 999, 1010. Well, the low value is 8. The high value is 10. The middle value, so the middle value of our set is 8. So here's, and we can see it's 9, but here's how you want to look at this. 8, 8, 9, 9, 9, 10, 10. So whenever I'm establishing the middle value, I like to take my set, my ordered set. Notice it goes from smallest to largest, and I simply cover up the ends, and then I work my way inward to show what that middle value has to be. As we see here, it's 9, so the middle value is 9. The lower quartile, well, the lower quartile is going to be the middle value of your bottom half. So here's the median, or the middle value. And we only want to concern ourselves with the bottom half and ask ourselves, what is the middle value? Well, cover up the ends and work your way inward, and you'll notice we essentially have 2 middle values for the bottom half, 8 and 9. So we want to choose the number that falls directly in the middle of 8 and 9, which, as you might anticipate, is 8.5. So recognize the quartile values do not necessarily need to be listed within the set. Okay, so for the upper quartile, we want to concern ourselves with the upper half, and then cover up the ends and slowly work your way inward. You'll see we have 2 middle values for the upper half, 9 and 10. So we need to find the number that sits in the middle between 9 and 10. As you might anticipate, that's 9.5. All right. And so now, from this information, we want to choose the box plot. Okay. So we have a middle value of 9. So throw out any box plot that does not have a middle value of 9. So it looks like B and C are going to be discarded. D and A are the 2 choices left. So in A, we don't see that box showing up, and that's essentially coming from saying Q1 equals the median equals Q3, so hence these 3 vertical lines essentially collapse into 1, and then we just have the high and low, with Q1 equaling the median equaling Q3. However, that's not the case in the data. So A does not seem like an accurate representation. So D looks like the best option. Now recognize the high value and the low value aren't listed here. Can we blow that up a little bit? And in fact, it seems as if the lower quartile and the low value and the upper quartile and the high value are close together, so we don't quite see those whiskers sticking out. So again, kind of a bad example of a box and whiskers plot. The 5-number summary for this guy, well, the low value is 7. The high value is 11. The middle value, still 9. The lower quartile, well, let's apply this same strategy. 7, 7, 7, 9, 11, 11, 11. And this is our middle value, or the median, 9. So if I want to find the lower quartile, I'm only going to concern myself with the bottom half of my data set and then find the middle value. So here's my bottom half. I cover up the first and the last and then work my way inward. Well, notice we have 2 middle values again. So we need the point that falls directly in the middle of 7 and 7, which would be 7. Similarly, for the upper quartile, we're only going to concern ourselves with the top half, cover up the last number and the first number, and you work your way inward. You'll see that we have 2 middle values. So, taking the average of those 2 middle values gives us the upper quartile. So, the middle value between 11 and 11, as you might anticipate, is 11. Draw a box plot for this one. Well, 7 is the low, 11 is the high. So 7 is the low, 11 is the high. And we have a symmetric box plot. So it looks like A is no good, C is no good. So the options are between B and D. We'll recognize the upper quartile and the high value are equal to each other. The low value and the low quartile are equal to each other. So these 2 quarter values will equal the high and the low value. So all we see is the box. And we don't see the whiskers. And that's a consequence of the quarter values equaling the high values. Or the upper quartile equaling the high value, the lower quartile equaling the low value. Five-number summary for this. The low is 5. The high value is 13. The middle value is 9. And so we should see the lower quartile for this would be 5. And the upper quartile value for this would be 13. Again, apply that same strategy of consider the bottom half and work your way inward. Consider the top half, and then work your way inward. So a box plot for this, well, yet again, the lower quartile is equal to the low value, upper quartile is equal to the high value. So between 5 and 13, well, C is no good. Between 5 and 13, well, A is no good. So it looks like only one of these actually falls from a low value of 5 to a high value of 13, and that would be D. All right. So compute the standard deviation for each set. Compute the standard deviation for this. Well, notice this is a constant set of 9, so the data values do not deviate. So the standard deviation is going to be 0. All right, so if we want to compute the standard deviation for 88,999,1010. We can go through the process that's listed in the notes. However, we do have a computer at hand, so we can open these data values in Excel. So if we click on this box and say open in Excel, alright, and then we have to hit enable editing, click in a blank cell and hit equals, and you want this cell to equals the standard deviation. So notice there are quite a few different ways to do a standard deviation. The function that we want for our purposes is the stdev, left parenthesis, and then highlight the data that you want to find the standard deviation of, close your parentheses, hit enter, and we see that the standard deviation is 0.816, and we want to round to the nearest tenth as needed, so rounding this to the nearest tenth. Well, 1 is not enough to round up my 8, so it's a standard deviation of 0.8. Alright. So we can open we can do the same process to find the standard deviation for this guy. You can open it up in Excel or simply change these entries to 7, 7, 7, 9, 11, 11, 11. And we see we have a standard deviation of 2. Compute the standard deviation for 5, 5, 5, 9, 13, 13, 13. 5, 5, 5, 9, 13, 13, 13. We get a standard deviation of 4. So recognize this first set had a standard deviation of 0, which means it's a constant set. The values of that set do not deviate, hence a 0 standard deviation. And then, well, they deviate a little bit in this next example. Instead of straight 9s, we have a couple 8s and a couple 10s. So the standard deviation increases a little bit. So you'll notice as these values become more spread out, you know, from only 9 to 8, 9, 10 to 7, 9, and 11, as these values become more spread out, recognize the standard deviation is increasing. This last set had the widest distribution. We went from a low of 5 to a high of 13, which in turn raised our standard deviation. So the higher the standard deviation, the more widespread the data is. So based on your results, briefly explain how the standard deviation provides a useful single number summary of the variation in these data sets. Well, a standard deviation is a measure of how widely data values are spread around the blank of a data set. Well, that would be the median. Yes, because you're looking at how spread your data is off the middle value. So our middle value in this case was equal to the mean. So I do believe that this is going to want mean. Typically, when you refer to your standard deviation, you're talking about how far deviated you're off of the average or the mean. Be careful in this example because the mean was also the median. We had a mean of 9, and every one of these sets that we looked at had a middle value of 9 as well, or a median value of 9. So note that the first data set, the difference between the highest and lowest value is 0, the first data set, meaning the straight 9s. And the standard deviation is 0, between the highest and lowest value is 0, and the standard deviation is 0. And in the last data set, the difference between the highest and the lowest value is, well, the difference between the high and the low was 8 in the last one, 13 to 5. which is higher than in the other data sets, and the standard deviation is the highest. So this last data set had the highest standard deviation. The first data set had the lowest standard deviation. So that's in fact the smallest standard deviation you can get. You cannot get a negative standard deviation. Moment of truth. All right. So that concludes homework 14. I'll let you try this one out. Do remember you can open up these values in Excel, and I would highly encourage you to use Excel in computing the mean and the standard deviation. Make sure you're utilizing the correct standard deviation in Excel. That's the STDEV. So that should be enough to get you going. Good luck. Let me know if you have any questions. I'll see you on the other one.